All right, pre-calculus kids, this is Miss LaFleur, and today we're looking at 9.3, geometric sequences and series. So a geometric sequence is similar to the arithmetic ones we looked at, but instead of adding and subtracting the same thing, we are multiplying, or you can think dividing, by the same thing each time. So they have a common ratio rather than a common difference. So they're the general form, notice here, and their recursive formula. So our general form, we have a sub n is found by taking the first term, which is a sub 1, and then multiplying it by the r n minus 1 times. So since it's repeated multiplication, that shows up as exponential. And then you've got your recursion formula where you always have to say whatever the first term is, and then you say every other number after that, a sub n, would be a sub n minus 1, the number in front of it, times your r. And of course, it's got to be greater than 1. So let's look how this actually works, okay? How to identify if it's geometric or not. Basically, we're looking to see, are you multiplying by something each time? Excuse me. So here, notice, this could be times 2, times 2, times 2. So yes, this is geometric. Geometric. And r is 2. Let's see, on B, notice here, each way, for this to work, we're multiplying by negative 3. So times negative 3, times negative 3 each time. So this is still geometric, and r is negative 3. But notice on part C, this would be plus 4, plus 4, plus 4, plus 4. So this is arithmetic. And this has a common difference of 4, so it's not geometric. The next one looks like they're dividing by 4, but instead of saying divide by 4, we're going to say multiply by negative 1/4. Okay, we're multiplying by negative 1/4. So yes, this is geometric, and r is negative 1/4. Now, when we are finding terms of a geometric sequence, we're going to basically use the formulas and make it make sense. So here we have find a sub 6. That means the sixth term, okay, of this geometric sequence. So notice they tell us it's geometric, okay, so that's important. That means we're multiplying by the same thing each time, and this would be times negative 5 times negative 5. Okay, so that means we know r is negative 5. So to find the sixth term, we'd say the first term times negative 5 times, so to the 5th power. And then, of course, you're going to plug all that loveliness in your calculator. Not expecting you to be able to do that without one. So the sixth term would be negative 9,375. Now the next part says find the nth term. And the nth term would be the first term, which is 3, times negative 5, which is our r, to the n minus 1 power. Okay, so that's the other answer they asked us to find. Now in part B, determine r and a sub 1 for the geometric sequence with a sub 4 is negative 8 and a sub 11 is 1/16. Okay, so that means our 11th term, which is 1/16, can be found by saying the 4th term, which is negative 8, times r. Let's see, how many times is that? That'd be 7 times. You know how I got that? Because from 11 to 4, there are 7 steps, okay? They're 7 apart. So that's where this 7 comes in. So now I'm going to divide by negative 8. So I get negative 1/128 equal r to the 7th. And now I want the 7th root. So yeah, there's a way to put this in your calculator. Math, and I think you tab down to the nth root thing. But basically, you're looking for the 7th root of negative 1/128. And you should get r is negative 1/2. Okay, so that's negative 1/2. And you can actually say, just do the 7th root of 128. And that might be easier and better in your calculator. Okay, so now that we know what r is, now we can find the first term. So we're going to say negative 8, which is our fourth term, is equal to our first term times 1/2 3 times. Because there's 3 spots to get to the fourth one. Okay, so let's see. I'd have to see negative 8. This would be a sub 1. This would be negative 1/8. And I'd multiply by the reciprocal, so I get positive 64 would be the first term. All right, let's look at example 3 here. When a radioactive substance decays, the amount remaining will form a geometric sequence when measured over constant intervals of time. The table shows the amount of an unknown substance initially and after 2 hours. Find the amounts left after 1 hour, 3 hours, and 4 hours. Okay. All right, let's see if we can figure out this. I know there are 2 steps here to get to that. So 384 is equal to the first amount, which is 1320, times r to the second power, because there's 2 steps. So that's 384 over 1320 is equal to r squared. So r would be the square root of whatever this is. Okay, so this is going to be a decimal. I'm pretty sure that's not going to come out nice and pretty. And we put that in our calculator, and we get that r is a little over 1/2, 0.539. So now I'm just going to plug it in and just say 1320 times 0.539, and that gives me about 712. I'm just rounding that off. And then I can do the next thing too, 384 times 0.539. And I get about 207, and times 0.539 of that, it's about 112. All right, so this next part looks at the sums of geometric series. Okay, so here's some formulas. You're going to need to know these and be able to use these. The ones you use the most, or the only ones I think you need to know, is this one and this one. I wouldn't really worry about this alternate form in the middle. Okay, I don't think that even makes a difference here, because all it is the top one distributing in your first term. So you're going to need to know those formulas on the next page to be able to work out your problems. All right, so let's look at these to work out. So notice they ask us to find the sum of the first 10 terms of the geometric sequence. Since we know it's geometric, that's important. Here we are multiplying by 3 each time. No, negative 3, right? Yeah, because we're changing signs. So we are multiplying by negative 3 each time. So sum of the first 10 terms. So first 10 times, okay, so this would be the first term, which is 2, and then we have 1 minus r. R we've already determined to be negative 3, and that's got to be to the n power, so it's 10, and it's over 1 minus r, and r is negative 3. So you're going to plug this in your calculator. This is going to be a little bit of a challenge here, because you've got 2, sometimes your calculator, depending on how you put this in, you know, it's very finicky. I would say definitely use your TI-84s here, because if not, your parentheses and all in the smaller calculators may become a problem. But you get negative 29,524. On example 5, find the infinite sum. All right, so the infinite one, that's the other formula, the one on the bottom. Okay, so it's S for the infinite one, first term, which is 1, over 1 minus r. And in this case, what is r? We didn't find that out yet. Let's see. We are multiplying by 1/2 each time, right? So this would be 1/2. So this is 1 over 1/2. Which is 1 times the reciprocal. So this is just 2. All right, let's see part B. Here they are multiplying by negative 0.6 each time, right? Yeah, so that's my r. So the sum of this one would be 1 over 1 minus negative 0.6, which would be 1 plus 0.6, so 1.6 on the bottom, 1 on the top. 0.625 would be the sum, so that would be like 1/8. So here's just using the formulas. Okay, so find the following sum. Now you certainly can, on this one, use your calculator. Okay, you can use your calculator on that one and just plug it in under math, and then that 0 option, you know, the one that says summation, you should get 6138. The problem, however, comes in when you see it's got an infinity symbol there. You cannot use your calculator on that one, okay, because you can't plug in an infinity. So you have to go back to the formulas, and it's the same one that you used right there. This would be first term, and if we plug in a 1 for n, it would be 2/3. On the bottom, 1 minus r, and r is 2/3. So you just got to know when you must, you know, use your formula. So 2/3 over, that would be 1/3, which is 2/3 times the reciprocal. So this one happens to be 2. Alrighty. One more page to go. All right, so on this last part, we are looking at using the geometric mean. Now, they're giving us a formula here, and you're more than welcome to use the formula to find the geometric mean that way. Most of the time, I use the other way, just making it make sense, but it's up to you. So if you want to use the formula, you can. Actually, you know what? Maybe I'll just do that then. Okay, to find the geometric mean, here we know it's 2 steps. I'm going to just do it the way I know. Okay, so 80 can be found by saying 45 times r twice, because there's 2 steps. So if I divide by 45, that gives me 16/9. And then if I square root that, that would be square root of 16 is 4, square root of 9 is 3. So that means I'm multiplying by 4/3 each time. So all I'm really saying is 45 times 4/3. And that cancels, see, that's 15 times 4, that's 60. So the missing one is 60. Now, if you wanted to use the other method, the one they showed us, we would find the number in the middle by saying the square root of 45 times 80, which will still give you 60. Okay, so your choice. I don't really care which method you use as long as you're getting the right answer. Okay, notice on part B, it's a little bit more of a challenge here because there's more spots. But if we have 1, 2, 3, 4 steps here, I know 12 is found by taking the 972 times r 4 times, right? Because there's 4 steps. So 12 over 972, and then of course we want the 4th root of this to get our r. So that's math, and you tab down to the 5th one there, put your little 4, and then type in your fraction, 12 over 972, and it gives us r is 1/3. So now I can easily find it by dividing by 3 each time or multiplying by 1/3. So this first one, 972 divided by 3. Okay, so the first blank in that box, is 324. That's the first one. Then divide by 3. Okay, then it's 108. And then divide by 3. It is 36. Okay, if you want to use their other method, you can. Just make sure you're getting to the right answer there. Okay, example 8, these applications. You make a contract with your parents to work 8 hours every day during the month of July. The first day, you'll be paid a penny. Second day, 2 cents. Third day, you get 4 cents. Fourth day, 8 cents, and so on. Is this a good plan for you, or do your parents get most out of the contract? So that means the first day, we have a penny, so 0.01. Second day, 0.02. Third day, 0.04. Then it's 0.08, and so forth. Every time it's doubling, okay? So that means to find, let's see, we want this. What would the last term be? So let's say it's 30 days. It's 30 days in July? I don't know. It might be. The 30th day at the end of the month, if we'd start with a penny, then it would be times r, which is doubling it, which is 2, r is 2, to the 29th power. All right, let's see what that comes up to be. So this would be 5,368,709.12. Wow. 5 million? Over 5 million. That's crazy. Yeah, I don't think your parents can afford that. I know mine couldn't. All right, so that means the sum of the 30 days, let's say it's just 30 days, okay, would be, if you start off with a penny, then you'd have 1 minus r to the 30th over 1 minus r, and you get like over $10 million. So this is over $10 million. So clearly, one, your parents can't afford it. Two, they just, well, your parents can't afford it, but that'd be great if they could, because that'd be amazing. And then the last one here, you're offered a starting salary of $35,000 for your first year with an annual increase of 5% a year. That means your salary will be 1.05 times what it was in your first year. What would you expect to earn in your 5th year on the job? Okay, so let's see, you're starting with $35,000, and then 1.05 is going up by that each year. The 5th year, you would have 4 pay raises because you don't get a pay raise on your first year. And you just plug this in your calculator, and that gives you $42,542.72. All righty, you have finished your notes for today.